Hello dear students, once again welcome to our channel Concept Corner. In this video, we are going to proceed our chapter Triangle of class 9. So let's start. In the last video, we have done exercise 7.2 question number 1 and 2 number was homework for you. Now today, I am going to start the question number 3 of the same exercise. Let's see what is the question. You will see the question from the book. I am reading the question. ABC is an isosceles triangle in which altitude BE and CF are drawn to equal side AC and AB. ABC is an isosceles triangle. This is a triangle ABC which is an isosceles triangle. Here AB and AC are equal. These two sides are equal, and what are given? BE and CF are drawn equal side. Altitude BE and CF are drawn to equal side AC and AB. BE, this is an altitude to side AC, and CF, this one is on altitude to the side AB. We need to prove that altitudes are equal. That means this BE and CF are equal. We have to prove this one. So what are given? Write first question number 3, exercise 7.2. Given, what are given? In triangle ABC, AB is equal to AC, then CF is altitude to side AB and B is altitude to side AC. That means BE is perpendicular to AC, CF is perpendicular to AB, and to prove, what we need to prove? That these two altitudes BE and CF are equal. We have to prove this one. So here, to prove BE is equal to CF. So let's start the proof. So we have to see in which two triangles these two sides are present, BE and CF. See, BE is present either in this triangle ABE or BEC, in these two triangles. But as we are given as AB is equal to AC, so we have to take this triangle ABE and ACF, since CF is present in triangle ACF. So by taking in triangle ABE and triangle ACF, in these two triangles, what are given? AB is equal to AC. It is given AB is equal to AC, given in the question. Again, this angle is common angle. Angle A is equal to angle A, common angle. Next one, see, in triangle ABE, this angle is 90 degree. In triangle ACF, this angle is 90 degree, because these two are altitude. So we can write angle AEB equal angle AFC. What? Both are 90 degree or equal 90. You can write both are 90 degree. So in two triangles, we have seen that three parts are equal. Corresponding parts are equal. Here, AB is equal to AC, angle A is equal to angle A, because this is common angle, and angle AEB and AFC are right angle. So they are also equal. We know in two triangles, if the three congruent corresponding parts are equal, then the triangles become congruent. So by what criteria? Two angles and one side. So angle side or side angle. By this criteria we can write that triangles are congruent. So we can write, therefore triangle AEB is congruent to triangle ABE is congruent to triangle ACF by what criteria? AAS, two angles and one side. Since the two triangles are congruent, so now we can write this side and this side. That means from these two triangles. Therefore, BE is equal to CF, CP, CP. So this one is the question number 3 solution. Next one, see question number 4. It is also same. So you are given homework this one. In the similar way you will prove. In question number 4, it is just you have to prove that these two altitudes are given equal. You have to prove that AB is equal to AC. Reverse of the question number 3. So you will prove this one. It is homework for A. Question number 5, see. Question number 5. You will see the question from the book. In triangle ABC and DBC have two isosceles triangle on the same side base BC. Figure is given. This one is figure. ABC and D. In this triangle, ABC and DDC both are present on the same base BC. Show that angle ABD is equal to ACD. Angle ABD, that means this whole angle and this whole angle are equal. We have to prove. In triangle ABC, this side and this side are equal. And in triangle BBC, DBC, these two sides are equal. So we need to prove that the two angles ABC, ABD and ACB are equal. So what are given? Given triangle ABC and triangle DBC are isosceles triangles on the same base BC. ABC also present on BC, DBC also stands on base BC. So to prove, what we need to prove here? We need to prove that angle ABD is equal to angle ACB. Angle ABD is equal to angle ACB. So to prove this one, you can solve it by two different ways. I am doing the easier one so that you get it understand easily. So for that, I will construct these two vertices are joined. Construction A and D are joined. AD is joined. Now proof. So in proof, since these two angles we need to prove equal, so let's take these two triangles ABD and ACD. If we can show them congruent, then their two angles will be equal. So in triangle ABD and triangle ACD, what can we write? Which parts are equal? In triangle ABD, this side AB is equal to AC of triangle ACD. So AB is equal to AC given. Again, this side BD is equal to CD. It is also given. AD is also present in triangle ABD and ACB both. So AD is common side. AD is equal to AD common side. Therefore, by three sides of this triangle are equal to three sides of this triangle. So by SSS criteria, these two triangles are congruent. Therefore, triangle ABD is congruent to triangle ACD by SSS. So since the triangles are congruent, so we can say that these two angles are equal because their corresponding angles here. Therefore, angle ABD is equal to angle ACD, CP. This one was very easy sum. So you will pause the video and write down the sum. I am going to next sum. 6 number, very important sum. This one 6 number. It is given triangle ABC is an isosceles triangle in which AB equal AC. ABC is an isosceles triangle. ABC, it is an isosceles triangle where AB and AC are equal. Side BA, that means this side, BA, not AB. BA is produced to D. This BA is produced, that means extended to D. This is D, such that AD is equal to AB. This AD is equal to AB. So that BCD is a right angle. BCD, that means this should be joined. This BCD angle is right angle. That means 90 degree. We have to prove the term. What are given? ABC is a right isosceles triangle where AB is equal to AC. Again, this side BA is produced to D, such that this part AD is equal to AB. We need to prove that this triangle BCD angle is right angle. It is observed that this is already right angle, but we have to prove it. So what are given? Question number 6 given triangle ABC is an isosceles triangle where AB is equal to AC. Then BE is produced to D such that AD is equal to AB. AD is equal to AB or AB is equal to AD. To prove, we need to prove angle BCD is 90 degree, right angle. We have to prove that angle BCD is 90 degree. So for that, first of all, take this triangle, this triangle ABC. In triangle ABC, we have AB is equal to AC. Therefore, we can write, since AB is equal to AC, so their opposite angles are equal. We know that angles opposite to the equal sides are equal. So AB is equal to AC. The opposite angle of AB is ACB, and the opposite angle of AC is ABC. That means we can write in triangle AB is equal to AC. Therefore, ACB angle is equal to ABC. ABC angle. Suppose this is one where angles opposite to equal side are equal. You will write this one. This one, suppose number 1. Again, in triangle ADC, in triangle ACD or ADC, ACD, we can write AD is equal to AC. Why AD is equal to AC? Because AB is equal to AC and AB is also equal to AD. You can write it since AB is equal to AD. So again, in this triangle, since these two sides are equal, then their opposite angle will also be equal. So opposite angle of AD is ACD. Angle ACD is equal to angle ADC. ADC. This is 2 number. In bracket you will write the same thing. Angles opposite to equal sides are equal. So now we have 2 equations in equation 1 and 2. So now we will take in triangle, since we need this angle BCD. So we will take this triangle BCD. In triangle BCD, in triangle BCD we can write angle ABC plus angle BCD plus angle ADC or BDC is 180 degree. Why 180 degree? Angle sum property of triangle. In bracket you will write angle sum property of triangle. Yeah. In the side of this line you will write angle sum property of triangle. So ABC, same. ABC, from equation 1 we can write ABC is equal to ACB. So you can write that ACB plus BCD remains same. And BDC. BDC means this angle. BDC and angle ADC is same angle. BDC angle and ADC. That means from ADC, ADC is angle. ADC angle is equal to what? ACB. That means ADC is equal to ACB. ADC means what? This BDC. BDC. So in place of BDC, what can we write? ACD. Angle ACD. Yeah, 180 degree. You can write from 1 and 2. From 1 and 2. So now say, write this part and this part together. Angle ACB plus angle ACD and BCD remains same, equal 180 degree. So this again see ACB. ACB means this angle. AC. This is C. ACB and ACD. ACD. These two angles together, this angle and this angle together make angle BCD. So you can write in place of this BCD. Again here BCD equal 180 degree. Now say there are two BCD, BCD plus BCD. That means two BCDs are there. So we can write twice of BCD equal 180 degree. Implies twice of angle BCD is 180 degree. So we need BCD. So BCD is equal to 2 is multiplying here. So if we divide both sides by 2, we will get here 90 degree, or 2 will go this side, divide 180, it will become 90 degree. So this is proof that angle BCD is 90 degree. So today for this much. Don't forget to subscribe, like and press the bell icon. Thank you for watching.